Good morning, everybody. Hopefully you had a good planning block with Ms. Wood. If you can give me some green check marks, we'll get started here once everybody checks in. Hopefully everyone's doing well today. Perfect. Some people signing in. I promised you guys I'd go through anything that you wanted today, and it doesn't really much matter to me. We could maybe break it up so we could do a bit of the midterm sort of review package questions today, and then we could maybe go back and do a little bit of the Unit 4 stuff, and then we could do a little bit of review again tomorrow. Just kind of depends on what you guys want and how many questions you have and things like that. So I'm kind of open and flexible with that. It might be of a benefit to do sort of kind of two little chunks of review, like maybe 30 minutes today, 30 minutes tomorrow, and just kind of look a little bit further into the Unit 4 stuff, but anything along those lines will work for me. So if you have any questions specific to the learning guide, I can do those. The midterm unit, the midterm review learning guide, there we go. Anything from the work we did in chapter 4 thus far, or anything in general. Alex, I see you throwing in some negative exponents. I could definitely go through some of that stuff. Midterm review 5A, C, and D. Which page, Taylor, or which section? I think it's broken up into a few sections. Anything else? Midterm page 4, question 5. I like it. I can find that. And yeah, well, I'll just kind of go, and if you have questions you want me to go through, I'd be happy to do them. I understand that it's likely that most of you haven't gone through the whole learning guide for the midterm review yet. So maybe we'll do a little bit today, and then we can maybe go back to Unit 4 for a little while and then go through a little bit tomorrow. Today's Wednesday, so we have Thursday's class. So we'll maybe go with that. Negative exponents, I see if I can find some of those questions, Alex. Midterm review 5 ACD, page 1, and page 4, question 5. So let's go page 1, 5 ACD to start. And this is A, C, and D. So this is kind of calculator stuff. And then the next one was page 4, question 5. When converting from one measurement system to another. Okay. And then Alex had just in general sort of negative exponent stuff. Let's see if I can find some examples of that. Maybe. Is there any one question specifically, Alex, that you've run into? I don't see a ton of them on here. Exponents. I guess there's just kind of general exponent laws. All right, maybe I'll make some questions up for you, Alex, and we can just look at them, hopefully. Figure it out? Okay, perfect. Works for me, Alex. So page 2, number 9A. That's a bit of a problem. Even mine's not formatting correctly, so. And simplifying radicals, A and C. All right, I'll get started with those, and then if anybody wants to put in anything else as we go along, I'd be happy to kind of go through that sort of thing. So number 5, evaluate to the nearest hundredth. And this is just basically using your calculator. So if you have a calculator handy, looks kind of like this. So the first one is 4 root 12. Sometimes with a calculator, you're going to have to enter these things separately. So with my calculator, to get to the square root, I have to go second x squared, and then it gives me that. And then I'd go 12, and then I hit the equals. And then if I want to multiply by 4 after, I just go times 4, and then I get my answer. So 13.856. It asks for the nearest 100th. So we have tenths, 13.856, we'll just go 13.86, would be the nearest hundredth. Maybe some of these, your guys' works and mine didn't. Maybe some of these, maybe look at C. Pretty well gonna have to do this in 2 steps unless you have a big fancy calculator. So if I jump over to my calculator here, I have 5 root 3 on the top. I'm gonna see if I can just enter this as 5 root 3 in my calculator, see if it works. So I go 5 square root and then 3. And then I just hit equals. And then I get 8.6602. So what I'm gonna do is I'm gonna carry a few decimal places in my question on the top. So I get 8.66, let's go 0.25. I don't want to round until the last step. I only want to round when I get to the very last step. And then on the bottom I have 4 root 7. So I'm going to go 4 root 7, get 10.58300 as my second number. Then I'm just going to divide these things. And I was showing somebody this fancy little button I have on my calculator. What I can do is, if I go back here, I got this 8.66025. So I'm going to go 8.66025. And then my calculator has this second answer, and I can just divide it by whatever the last answer that came up in my calculator was. So that was the bottom. And the reason I do this would be to carry as many decimal places as I can. So on the top, I've estimated it at 5 decimal places, but if I use the calculator's memory, then I get a bunch more decimal places. So I get 0.818. Which is going to be 0.82 to the nearest hundredth. So, Taylor, if you're having issues with your calculator, it's one of these things I can't really help you with until I see your calculator. And then even then, it's best to just kind of start with a really simple example, and then you can kind of work from there. So don't start with these really complex ones. Your calculator may be a backwards type calculator where you have to put in, like, if we look at the first example here, 4 root 12. If you, on your calculator, might have to type 12 and then hit the square root button and then hit the equals button and then hit the multiplication button and then hit the 4 button and see if you get this 13.86. And Abby's saying, yeah, I usually just type in a bunch of decimal places and then punch it in, and that works, but then you don't want to be writing down all these decimal places. As a general rule, if it asks for an answer to the 10th, if you carried an additional 2, that would be good. If it asks for an answer to the 100th, if you carried an additional 2, so you carried 4 decimal places, generally speaking, you're going to be close enough that it won't make any difference. So there you go. So hopefully that kind of helps a bit. Taylor, mastering a calculator is half the battle. And once you get it, you shouldn't have any issues with these questions because it's just a matter of plugging them in. So let's just meander on down to the next spot here. Simplifying, leave in the simplest radical form. I'm not sure why this all of a sudden didn't work. I think it was working before. Can anyone tell me what sign is in here and what sign is in here? That would be stupendous. While you're doing that, the first thing we do when we see a simplifying radicals question, we say, are there any radicals that I can simplify? Are there any perfect squares that go in here? So can I pull a perfect square to 2 or 6 or 10? And well, they're all multiplication signs. Thank you, Ava. So I'm multiplying here. So there isn't anything I can do to simplify these any further. It's different for everyone, apparently. We'll just hope it's multiplication and go for that. So we're just multiplying these things. When we multiply radicals, we take our constants out front and multiply them, and then we take our radicals and multiply them. So 2 times 6 is going to give us 12. And then root 2 times root 6 is root 12. And then I have this 3 root 10, which I will deal with now. So 12 times 3 is going to give me 36. And then 12 and 10 is 120. I'm thinking you guys are getting these weird like greater than or less than arrows. I'm thinking it's probably maybe a multiplication question. We'll see where we end up. Let's do it as a multiplication question. The other two are multiplication questions, so let's just go with it. Once I get to this spot, I have this 36 out front, which I'm not going to do anything with, but I have this 120 under the radical sign that I need to simplify. So I need to figure out the largest perfect square that goes into 120. I don't know. 4 and 30 is 2 and 15. Is there anything bigger than 4? 30. I'm thinking 4 might be it. So let's pull out, let's break it down a little bit further. So we have 36 and then 4 times 30. Square root of 4 is going to give me 2, and then root 30. And 36 and 2 is 60, 72, root 30. How did I get 12 from 2 times 2? That's a good question, Shayna. That definitely is not a 12. So this needs to be adjusted. I was looking at the 2 and then the root 6, and that's just a silly mistake. So it was definitely a 4. Sorry about that. Thanks for catching me. 4 times 3 is going to give me 12 out front. 12 times 2 is going to give me 24. No, thank you for pointing it out, Shayna. It's good. That's why you guys are here. Catch me, make me honest. So that makes more sense now, hopefully. And thanks for that, Abby. So 24 root 30 is where we end up. And then 30, are there any perfect squares that go into there? If I think about the factors of 30, I can get like 1 and 30, 2 and 15, 3 and 10. None of these things are perfect squares. So yeah, I'm thinking there's nothing we can do to further simplify that. So that was 9a, which we did. 9c, what's going in front here and in here in my boxes? Are there negative signs in there, or is there something else happening? If anybody has a version that doesn't have boxes on it, could help me out with that. I'll just rewrite the question up above here. 2 plus root 5. And we're multiplying it by 3 plus 3 root 5. They're both negatives, so negative 2 and negative 3. We'll go with that for now. And here's there isn't anything. Everybody's doing a different question. Choose your own adventure. Sorry. You don't have anything. I'm going to go both negatives. I have a feeling that's why they're there. We'll just go with that. All right, so this is a FOIL scenario where we have two terms in each. So we need to go first times first, second times second, insides, and then last. So the first thing I'm going to do here is go the negative 2 times the negative 3, and then the negative 2 times that. So I'm going to get positive 6. I'm going to get negative 6 root 5. And then I'm going to get a negative 3 root 5 from my insides. And then my lasts. My last is going to give me positive 3 root 25. So the 6, negative 6 root 5, combining like terms, negative 9 root 5. And then 3 times the square root of 25 is just going to be the square, it's just going to be 3 times 5. So it's 15. I'm going to add my 15 and my 6 to give me 21 minus 9 root 5. I'll just go with that, being their negative signs there. If it was just nothing, then fair enough, there's nothing there. It just changes a little bit of the question, but the general idea behind it is probably the same. So sorry that didn't work properly. I think I loaded the Word document, and then the PDF should be good. So I re-uploaded that PDF. And if you are running into issues with answers in the key because of the boxes that are showing up, then just let me know and we can try to figure it out. But just do your best to try to sort it out. Obviously, if you don't have any of those boxes showing up in your document, you downloaded the PDF, everything should be fine. But if you're getting those boxes, then just be aware that when you get to the end of a question, you might end up getting a wrong answer, but it might be right because you don't know what the box was. So that was 9. I think there was another question that I missed. I think page 4, number 4. 3. So 4 and 5. The vernier caliper has 2 scales, the main scale and the vernier scale. Explain how these 2 scales are used to measure an object. Okay. And then when converting from one measurement system to another, you can use proportional reasoning or unit analysis. Explain using an example the difference between using proportional reasoning and unit analysis to convert between SI and imperial. All right, so kind of 2 conceptual questions. Let's get the caliper one out of the way first. So the first unit was, let's see if I can find the caliper questions here. Okay, so here's a question. We'll pretend we haven't done this one yet. It's talking about the vernier caliper, and it says there's 2 scales. So when it's talking about 2 scales, you have this scale here. There's your one scale, which measures millimeters. And then you have another scale here, which measures 1/10 of a millimeter. So this is just going to give you more accurate measurement. So the way we read the caliper is we look at where the 0 falls. So we read the 0 on the first scale. So this is 11, 12, 13, 14. So there's our first scale. We read the 14. So we know we're going to have 14 point something. Everything on this scale is reading to 1/10 of a millimeter. So I need to figure out which one lines up. And it turns out the 3 is lining up. So we go 14.3. So the way we read it is we use our first scale up here, and then we use our second scale down here at the bottom. So that is, again, how we use these calipers. Common spot students will make mistakes is they will try to read where the front of the caliper lines up instead of where the 0 actually is lining up. So you always want to make sure you're reading from the 0 instead of the front. Do not use the front of the caliper. Just use the 0. The micrometer questions, I mean, they're there. Why 0.3? The 0.3 is where if we look on the second scale, Taylor, we're looking for any of these things to be in a complete vertical line. So this 1 is just a little bit behind the line. The 2 is again behind it. The 3 looks pretty good, and then the 4 is now on the other side of the line. The 5 doesn't line up, the 6 doesn't line up, the 7 doesn't line up. You see how these are all not lining up? But the 3 is lining up perfectly. So we use 14.3. So micrometer type questions, The reason I didn't spend time on them is they don't come up very often, but we can go back to the course and look at a micrometer question, I guess. Let's bring up the micrometer simulator. It was just something that I've only maybe seen one or two micrometer type questions on a exam in the last like 5 or 6 years, so it's not necessarily the most important thing. All right, so the micrometer, it's going to be really hard to do with my mouse. The micrometer works the same general way as the caliper. There will be no micrometer question on the midterm, but it's worth talking about. So if we look at how a micrometer works, the distance inside the micrometer here is going to be a lot smaller than a caliper. So micrometers are used, and they're even more accurate than a caliper. So they're even more accurate in terms of the distances that they're measuring. If we look at our micrometer, these are half a centimeter. So I have 0, and then each mark here is measuring a half a centimeter. So, or half a millimeter, I should say. So every time you see one of these little lines here, this is half a millimeter. So you have half there. If I start to pull it back, you can see that this dial is turning. It's hard to visualize here, but if you think about it this way, so this is half a millimeter, this is another half, this is a half, this is another half, this is another half, this is another half. So 0.5, 1, 0.5, 2, 0.5, 3, 0.5, 4, 0.55. So this is 5 millimeters. So it's kind of deceptive at the scale that we're dealing with, but this is only 5 millimeters right here. This is 5.5, 6, 6.5, 7, 7.5, and so on. So that's the first scale you're going to read. The second scale is the one that here is right here with the green line next to it. When you see this 25 is going to be 25 after this. So if this is 5, this is 5.5, this is 6, this is 6.5, this is 7, this is 7.5, and then we're adding another 25 onto it. So if we were to total this, we'd get we get 5.5, 6, 6.5, 7, 7.5, plus another 0.25, because it's telling us this is 0.25 millimeters. So we have 7.5 plus another 0.25, so this should be 7.75. And if we look down at the bottom, we zoom out, we see that this in fact is down here at the bottom, 7.75. So the way the micrometer works is you have two scales. You have this big one for, it's called like the coarse adjustment, and then you have a fine adjustment on the end. The most important thing would be to just recognize that this micrometer is measuring very, very small things. So each one of these dashes is 0.5. And your micrometer actually might be a little bit different than this, but that's just kind of the way this one worked. So I don't know, let's look at another example here. So there's 10. When it's just lined up perfectly with this at the 0, you have exactly 10, and it says 10 down here. If I pull it out a little bit farther, we end up with, there's 10.5 right there, and then I'm lined up with 0 again, so that's 10.5. Let's try to go between two numbers. This one's a little bit trickier here. So we have 10.5 is right here, and then we have 11, and we're not yet at 11.5, which would be down here, but we can't see it. So we're at 10, 10 and a half, 11, and then this is why I don't like this micrometer thing very much. Let's go to one there. That's the same one. I'm trying to get in between. I don't like that. So this is 3, 5, and this is 4 up here. So we're breaking the 35 into how many pieces? 36, 37, 38, 39, 40. All right, so we're midway between, and this is tenths, hundredths, and thousandths of a millimeter. So we're at 0.35. This is 3.6, this is 3.7, and we're halfway between 3.7 and 3.8, so 0.375. So this is going to be, we have 10, 10 and a half, 11, and then we have 0.35, 3.6, 3.7. This is 3.8 up here, so we're at 3.75, just in the middle of the 3.7 and the 3.8. So that should be 11.375. And if I just get out of the way here for a second, you can see it's actually cutting off the 5, but you can see the 5 up here. So that's how we use a micrometer. It doesn't come up very often. It's not going to be on the midterm, but now you know. So there you go. A few other things came into chat while I was dealing with that. So it could be a question on the provincial and one question wrong could be the difference between A and B. You're definitely right. It definitely could be. They don't come up that often though. So hopefully that helps. Now you know. So there's a few more questions here. What else do we have? Page 6, numbers 3, 4, and maybe 7A. Five, 6. Am I getting that right? Is it Jade? Page 6, numbers 3, 4. And then 7A, I assume that's on the following page. Okay. So these are asking for the column method and using the area method. And I mentioned this in the course. It's really kind of one of these things where if you know how to expand, doesn't matter how you're doing it. Now, the curriculum actually states that you should be able to do it using sort of visual type examples, like using the column method and the area method. I personally don't see a lot of value in it, but if it helps you understand it, then perfect. So when you come to a question like this, and this isn't just specific to Jade, but everyone, if you know how to expand it and multiply it out, then just do it. You're going to get to the right spot. It's really difficult on a provincial exam or even a test for somebody to say, you must do it this way. You can do the question however you want. There's no requirement for you to do it one particular way. So if you can expand these, just expand them. I'd said when we went through this in the course, if you wanted to look at the column method, there was a lesson built into the course that had the column method. If you wanted to look at the area method, there was a lesson built in there. I'm just going to teach the one method, the just sort of normal, expand, distributive property of multiplication. If you want to learn one of the other methods and it makes more sense to you, then by all means, go ahead and do that. So I have no issues if you just simply expand these. Now, with Jade, maybe I should ask the question, do you want me to expand it, or were you kind of caught up on the column method or the area method for these two guys? I have a feeling you're probably pretty strong at the sort of multiplication aspect of this stuff, but you can correct me if I'm wrong. Okay, I will expand it for sure. I can do both, in fact. So when we multiply these things, we need to go the first term times everything in the second bracket, and then the second term by everything in the second bracket. So I think I use kind of two colors to try to describe this. So I'm going to go this guy, 4a times 3a squared. So when I multiply, I need to multiply the numbers in front of the variable, and then I add the exponents of my variables, because we know our exponent laws. If we're multiplying, we add exponents with same bases. So I'm going to go 4 times 3 is going to give me 12, and then a I have an exponent of 1 here and an exponent of 2 here. So I'm going to add those together to get 3. So that's my first step. And then we're going to do the same thing here. 4 times 2 is going to give me, in this case it's negative 2, so negative 8. And then I have a to the power of 1 and a to the power of 1. I add my 1's together and I get a squared. Then I'm going to do the same thing again. I'm going to take my 4a and multiply it by 7. So 4 times 7 is going to give me 28. And then a, just the power of 1, nothing else to multiply it by. So that's my first term, my 4a, multiplied by everything in the second bracket. The second step is taking this 2 now and multiplying it by everything in the second bracket. So I'm just going to do it kind of one step at a time. So the first one here, I'll just change color so you kind of see where these are coming from, but you definitely don't need to do this in 2 colors when you're doing it. 2 times 3 is going to give me positive 6. A squared times just basically 1 gives me a squared. Then I'm going to go 2 times negative 2 gives me negative 4. And then I have this a just hanging out. And then 2 times positive 7 gives me 14. So I've now multiplied the first term, the 4a, by everything in the second bracket. I've also multiplied the 2 by everything in the second bracket. So essentially I've made sure everything was multiplied by everything, and that's kind of how we want to do these types of things. At this point I want to combine any like terms I have, so I need to kind of, figure out what's the same. So I look at the exponents of my a's. I have a squared here, and I have a squared here. So I know I can combine those. I have 28a to the power of 1, and then 4a to the power of 1 as well. So I can combine those. And it looks like the 12a cubed out front here doesn't have anything to be combined with. So I'm just going to leave it and bring it down. Same thing with the 14 on the end. There's nothing to combine that with, so I'm just going to kind of drop it down to the next line. So I have 12a cubed, which just comes down from above. Now I look at my a squareds. I have negative 8, and I'm going to add positive 6. So that should give me negative 2a squared. Then 28a's minus 4 is 24a. And then I'm just going to drop down my 14 from above as well. So that is it. That's as simple as we can make that. We've multiplied everything. We've combined like terms, and that's just as far as we can go. So if we make it that far, we're doing okay. The next question is just the exact same except using the area method. So I'll leave you to that. I'm just going to leave it at that. The column method, basically, you write the 2 things on top of one another, and then you just add them vertically. The area method, I don't even know how to do it, to be honest with you. I know you draw like a rectangle and write the 4a plus 2 on one side and the 3a squared minus 2a minus 7 on the other, and then you put the area in the middle or something like that. I just find that these just kind of confuse actually just doing the multiplication and adding like terms. So steps that kind of, in my opinion, aren't really necessary. But if you want to learn those methods, they are there in the course and you can have a look at them. There you go. So doing 4 is kind of, if you want to use the area method, you can, but it's the same question as above. So not really necessary to kind of do it. Abby and Ava had the same question, so you can definitely go further. You broke up the polynomials further. I'm not sure I understand what you mean by that. Oh, for the area method. So you take like the 4a and then the 2 and then go from there. That would make sense, I suppose. Then the 2 below it. Okay, yeah. So in any sort of method you're choosing, you're doing the exact same thing. You're just representing it sort of different ways. So it's kind of like a more visual way to do it, the area or the column method, than just kind of doing the multiplication. So I'll leave you to that if you want to go with one of those methods. Page 5, number 5, page 4, we definitely have time. Number 5, page 4. Oh, I circled it, but I never actually did it. I got caught up in the caliper and the micrometer questions. Sorry about that. When converting from one measurement system to another, you use proportional reasoning or unit analysis. Explain using different examples, difference between proportional reasoning and unit analysis. Now, when I did these type of questions, I almost exclusively did unit analysis. So I don't know, let's look at an example. Maybe let's convert 2 feet into inches. So 2 feet is how many inches? There's my example. So this would be a unit analysis type method. I'd go 2 feet and I'd multiply it by, I know I want to get an answer in inches because that's kind of what the question I've chosen. Then I go to my formula sheet and I see the relationship between feet and inches. So I know that I want to put feet on the bottom because it's going to cancel, and I want to end up with an answer of inches, so I put it on the top. So I know that 1 foot is 12 inches. My units cancel, and then I'm left with inches. So I'm going to end up with 2 times 12, should give me 24 inches. So that would be a unit analysis type method. The other one is proportional reasoning. So this one, honestly, I never really use it, so I'm not super confident with this, but I know 2 feet, the relationship between feet and inches is 1 foot is 12 inches. So I have 2 feet. How did I get from 1 foot to 2 foot? Well, I just multiplied it by 2. So what am I going to do on the other side here? I'm going to multiply this side by 2 as well. So I'm going to end up with 24 inches. So that's more of a proportional reasoning type solution. You're using the relationship between feet and inches, kind of moving from one to the other. You're going to multiply the first thing by 2, so you multiply the second by 2. So that kind of deals with the proportional reasoning. So this is kind of getting back to the same problem we were just looking at. There's 3 ways to expand the polynomial, and in this question we've used 2 methods to find the same answer. We have the proportional reasoning method and then the unit cancellation type method. Whatever one works the best for you. I personally, moving forward in your kind of math and science careers, this unit analysis one is the one you're going to see the most. So I strongly encourage you to use the unit analysis method because it'll make your life easier. But if you want to do it a different way, then there's nothing wrong with that. Now, Alex asked a few questions about negative exponents, so I wanted to make sure I got to those. And then I see a few more questions that kind of tinkling into chat here. So maybe let's go down to the exponents stuff, and then we'll take a little look at this, and then hopefully I'll answer any questions you have. So negative exponents, what's the first column here? All right, so we have, x to the power of negative 1. We need to rewrite this. And then include an example. All right. Yeah, for sure, Abby. Thanks for sticking around. We will see you later. So x to the power of negative 1. What does this mean? This means when we have a negative exponent, we need to take the reciprocal. And meaning reciprocal just means flipping the thing. So let's say we had 2 to the power of negative 2. when we say take the reciprocal, what we're going to do is we're going to flip it. So this was 2 over 1. We don't ever write that over 1, but that's what it is. And then we need to flip it. So I'm going to rewrite this as the exact same thing, 1 over 2 to the power of 2 now. Now both things inside the bracket get the exponent of 2, but on the top, 1 to the power of 2 is just going to give me 1. So I'm just going to add 1, and then 2 squared is going to give me 4. So there's an example of kind of how a negative exponent would work. So we did some, I guess, trickier questions where we had negative exponents and fractions as well. But at a very basic level, this is how our negative exponents are going to work. I see, Alex, you kind of popped out and back in, and you're in. So I'm hoping you're going to stick with us here for a second. Maybe I'll do a couple examples of sort of negative exponent type questions over here. And then, Alex, if I answer your question, then we'll go from there. Let's go 27 to the negative 2 over 3. Okay, I see what you got there, Alex. I'll do this one first, and then I'll try to answer that question you just put in. So 27 to the negative 2 over 3. I have a negative exponent, so I'm going to take the reciprocal first. So this was 27 over 1. So this is going to be the same thing as 1 over 27. That's flipping it to the power of positive 2 over 3. So I mentioned this when we were doing the course, when we were kind of seeing this for the first time. The most common place a student will make a mistake is when we're doing these exponents, students will actually take the negative exponent and they'll flip the exponent instead of flipping the 27 and the 1. If you're going to make a mistake, that's where it's going to be with these type of questions. So I'm going to finish this guy off here. We know whatever's on the bottom is going to be our root, and then whatever's on the top is going to be our flour. So flour is the power, root's the root. So I'm going to take the, I'm going to both the top and the bottom, the third root of everything squared. So the third root of 27 is going to be 3. And on the top, the third root of 1 is 1, and 1 squared is 1. So everything on the top is 1. Writing it this way was just completely unnecessary, but just to kind of clarify my thought process, that's what I was doing. We do the top and the bottom, but in this case, it was just 1. The third root of 27 is 3. 3 times 3 is 9, times 3 again is 27. And then we get squared. So we end up with 1 over 9. The next type question here you were asking, Alex, is, forgot how to calculate third root on my calculator. I'll get to that in a second. I'm going to answer this. What if it was 4 to the negative 3? So we have 4 to the negative 3 over 3 to the negative 4. Something like that. Is that hopefully what you intended by that? I guess an easy way to kind of think of this is you could kind of think of it as 2 separate questions. Now, generally in math, we wouldn't write it down as multiplication, but this is the same thing as 4 to the negative 3 over 1 times 1 over 3 to the negative 4. Now, I wouldn't typically write this step, but if we multiply fractions, we go top times top, bottom times bottom, and that's what we'd end up with. So maybe it makes it a little bit easier to see it this way. I have a negative exponent, so I'm going to flip this thing. Instead of 4 over 1, I'm going to get 1 over 4 to the positive 3 now. And then I'm going to multiply that by, same deal here, I'm going to get 3 over 1 to the positive 4. So I've just flipped it. If I multiply these things back together, I would go 3 to the 4 over 4 to the 3. And then I could actually calculate what those exponents are, and I could go from there. What I would do at this step is normally I would just go, okay, I have this 4 with an exponent of negative 3 on the top. So I'm just going to move it to the bottom. and make it a positive 3. And I have this 3 on the bottom with an exponent of negative 4, so I'll just move it to the top. So it would just end up there, which is the same thing as what I had over here. All I did was just just breaking it down. So this is what I would normally do over on the left. If you want to think about what actually is going on the right, you can look at it there. Perfect, Alex. Glad to hear it. Third root, Jade, on your calculator. Depends on the calculator. My calculator has a third root button. So if you have a calculator with a third root button, you can use it. Mine, you can also go 3, and then I go shift and hit this guy. And just up above, it has a little X in front of the root. So if I wanted to know the third root of 27, 3, little X root, 27, so that equals 3. You have a TI-83, Jade, then you're going to use the hat. Unfortunately, there's no easy way to do it on the TI-83. So Jade, you're going to go 27 hat. Mine is an X to the Y button. And then 1 divided by 3. So third root. And then you should end up with 3 there. So Jade, yours is going to be the little hat. And if you're doing roots with the TI-83, you have to use fractional exponents for roots. Hopefully that helps you a little bit. Remembering that anything in the power of 1/2 is the same thing as the square root of the thing. And then if you had x to the power of 1/3, that's the same thing as the cube root. So that's why you're using the little hat, and then you're using bracket 1/3 on your TI-83. Let's jump back into chat here. 3 to the negative 3/4. I did that. TI-83, Ava. Why in our exponents unit did we take exponent and apply it to everything inside the brackets? So 2 exponent 2, but in our polynomials we just repeat it. That's a really good question, Ava. So the kind of the difference that we run into with the polynomial unit as opposed to the other unit was this, and it might not be super apparent right away, but when we had something like, I think you said like 2x to the exponent of 2, both things inside the bracket got our exponent, and we did it that way. So mathematically speaking, that's fine. In the polynomials unit, the difference is if we have like 2x, y, 3y squared. Why do we have to write this thing out twice? Because we have this addition sign in the middle between our two polynomials. So in the first example here, kind of in the exponents unit, we weren't adding or subtracting things inside the exponents. But now when we are adding and subtracting things inside of the exponents, we need to actually write the thing out twice and multiply it because of sort of order of operations rules. So we can't just take the 2 and give everything in the bracket the 2, because these things are being added together essentially. And that's just how we do it. I'm sure there's a better way to explain that. I can't think of it right now. But that is the difference between just giving the exponent to the two things as opposed to actually writing it out twice. If we have addition or subtraction between the things, then we have to write it out twice. So that's kind of a good rule to go by. Page 4, number 8. 12 to the -7, 42 to the +3. Page 6, top 3, B, and C. All right, thanks. Taylor, go to your question, then I'll get back to you, Alex, and then I will get to Talia's other question. So page 4, number 8. If a sphere fits into a cube that has side length of 80, what is the volume of the empty space? Oh, you had to pick like a long one for me to do. All right, so we have a cube, And we have a sphere inside it, which is going to be difficult for me to draw, so I'm just going to represent it as a circle that you can kind of see there. The cube has a side length of 80, the volume of the empty space. So if this is 80, this is the radius of my sphere is going to be 40. So radius is going to be 40. So volume of a sphere is 4/3 pi r cubed, and the volume of our box is going to be length times width times height, or just length cubed, because in this case it's a cube. So 4/3 pi, radius is 40 cubed. The length of one side of my box is 80. Does anybody have a formula sheet, volume sphere, 4/3 pi r cubed? Just want to double check that for me. I'm just going off the top of my head. 4/3 pi r cubed. Let's do it in a calculator. 4 divided by 3 times pi times 40 cubed. Is a big number, which makes sense, I suppose. So this is 268,082. The box is just going to be 80 cubed. And 80 cubed is 512,000. So these are centimeters cubed. What is the volume of the empty space between the sphere and the cube? So all I'm going to do is take the volume of the box, and I'm going to subtract the volume of the sphere, and that should give me the empty space. So this 512,000, I'm going to subtract 268,082, and I end up with 243,918 as the empty space. If you put brackets around the R, it becomes a rainbow. Yeah, you have all these little smileys you can use in chat, and they all have little shorthands that you can see right down in the bottom here. When I hover over them, they all show up. So if you're wanting to put in like a smiley face, or like no is N with a bracket, there you go. Alex got the rainbows all figured out. I have 3 minutes. There was a couple more questions that showed up here. 12 to the negative 7 over 42 to the positive 3. 12 to the negative 7, 42 to the positive 3. All right, so as good of a question as any. So 12 to the negative 7, to make it positive, I'm going to move it to the bottom. So all that's going to be left on top is going to be just a 1. Because, again, if I wrote it a different way, if I went 12 to the negative 7 over 1 times 1 over 42 to the power of 3, and then I flipped this guy, so I went 1 over 12 to the 7 times 1 over 42 to the 3. All I have on top is the 1. And then the order of multiplication on the bottom doesn't matter. So 12 to the 7 times 42 to the 3, something like that. That's how we flip it. So we only need to flip the thing that's getting the negative exponent. So in this case, it's just the 12 to the exponent 7. We don't have to flip the whole thing because this 42 to the power of 3 on the bottom has a positive exponent. I guess where you might be getting confused there, Taylor, is that we need to deal with sort of each thing with its exponent separately. So the 42 didn't have the exponent of 7. The 42 had the exponent of 3. So we don't want to give it a 7 when we're only saying 42 to the power of 3. The 7 is dealing with just the 12. So if I have the negative 7, I just move whatever it was to the bottom, and that becomes a positive. So if the positive exponent's on the top, yeah, if it's positive, it stays where it is. So the 42 was on the bottom with a positive exponent. It stays the same. Another way to think of it, if I had like 2 to the negative 2, 3 to the power of 2, x to the power of 4, over, I don't know, 3 to the power of 2, 2 to the power of negative 2, x to the negative 2. So which ones am I moving? Well, this has a negative exponent, so I'm going to move it to the bottom. And this had a negative exponent, so this whole thing is going to move to the top. And this had a negative exponent, so it's all going to go to the top as well. So this 3 squared is going to stay on the top. And my 3 squared down here is going to stay on the bottom, where it was. This 2 to the power of negative 2, I'm going to move to the bottom. So it's 2 to the power of positive 2 now. This 2 to the power of negative 2 on the bottom is going to go to the top and become 2 to the positive 2. I had this x to the 4, which was positive up top, and then this x to the negative 2 is now going to become a positive 2 on the top. And then we can simplify it. We say, okay, 3 to the 2 cancels with 3 to the 2, 2 to the 2 cancels 2 to the 2, and I end up with x to the 6, adding my exponents. So that's kind of the next step, or simplifying that sort of question. Hopefully that helps. What if it says simplify completely? So that's just kind of through that little bit. That's kind of it for today. I'm glad we got through some of those questions. If you have more questions, I'll be happy to answer them next day. I would like to get a little bit of Unit 4 stuff done. So you can bring those with you next day. There's a few people coming in today at 1 to do some math with me. If you want to come in, be good. Taylor, you're going to have to remember that for next day because we've run out of time for today. So any other questions you guys have next day, I'd be happy to answer them. But for now, we're going to sign off. So we will see you guys later, and have a good afternoon.